Hi, we're going to go ahead and talk about compound interest here. We're not only going to be talking about interest that's compounded a specific number of times a year, but we're also going to be looking at interest that is continuously being compounded. And at the end of this section, we're going to look at the effective annual yield, which is finding the simple interest rate for money that's being compounded. And we'll get back to that. But to start off here, we should probably look at the compound interest formula. If you are, let's say, investing your money, then you're investing a certain amount in the beginning, you're earning a certain interest rate back, and when that interest is being put back into the account, the time after that, so maybe the following year, you are earning interest on the interest that was being put back into your account. So that action of your interest earning interest is where the word compounding comes into play. So in the very beginning, I'm going to look at a formula where your interest is being compounded once a year. And we're going to go ahead and talk about the different parts of this formula. So this is when your money is compounded once per year. So if your problem says something about your interest being earned annually, then this is the formula you're going to be wanting to work with. So let's go ahead and talk about the different variables that are here. A stands for the future value. I like to think of it as the account balance. So once the interest is being added back into the account, what is the account balance? So what will the account be worth? B is the present value, which I like to think of as the initial value. How much did you initially invest? If you're talking about borrowing a loan, how much did you initially borrow? Or whatever you were buying, what was it initially worth? It's also called the principal. So for example, if you're talking about investing $1,000 and you're asking how much will it be worth in 10 years or whatever, the present value or the principal is the initial value. So you invested $1,000. That was the initial amount. R is the interest rate. Make sure that you are always converting the percentage to a decimal. So you should always be rewriting it as a decimal when you plug it into this formula. T stands for time. So you're looking at how long is your money actually sitting in that account. It's usually in years. So if it's given to you in months, so for example, if you say that your interest is being compounded annually, how much is going to be in the account after, I don't know, 18 months? Then you're going to want to convert that to years, which would be 1.5 years. So you'd end up plugging 1.5 in for T. Now, T is different than the number of times that your money is being compounded a year, because that's the number of times it's being compounded. It's talking about how many times the interest is being added back into the account, whereas T is how long is your money sitting there in that account. Okay, so let's say that you invest $750 into an account that earns an APR, or an annual percentage rate, of 6.5%. How much will be in the account after 8 years if your money is being compounded annually? So we're going to be using that same formula as before, where we have A equals P times 1 plus R to the power of T. We're looking for the future value because we're wanting to know how much will be in the account eventually, which means A is what we're looking for. P is the amount that we initially invested, so that's going to be 750. R is the interest rate. Remember, we have to rewrite that as a decimal, so 0.065. And then we're looking at the money sitting here for 8 years. So you're going to put an 8 in for T. I would encourage you to pause the video here and make sure that when you plug it into your own calculator that you get the same thing. Now in my calculator, I'm going to type 750, put a parenthesis, 1 plus 0.065, put another parenthesis, and then I have a button that has this on it. Oh shoot, you can't see that very well. It looks like this. That's going to do the exponent spot for me, and then I'm going to go ahead and type the 8 and press enter. So I get A equals 1,241, and if I have the cents here, about 25 cents. So the account will be worth $1,241.25. Now, if your calculator does not have this button, you might have something that looks more like this. Just kind of depends. So you might have to use that to get the exponent spot. If that's the case, then you're probably going to have to work a little backwards. Reach out to me if you're not sure how to plug it into your calculator. Okay, so let's say that maybe instead you have a problem where you are given how much you want the account to end up being worth, and you have to find the initial amount. So that would be a problem like this. If you plan to invest money into an account that earns 7.85% interest compounded annually and want to invest $8,000 in 4 years, you want to have $8,000 in 4 years, how much do you have to invest initially? Well, we're going to use the same formula as before. This time, the money is that the dollar amount that we're given is what we want the account to end up being worth, so that's the future value. So that means I'm actually plugging 8,000 in for A. And the initial amount is what I'm looking for, so I leave P alone. Now it tells me that the interest rate is 7.85%, so that's going to be 0.0785. And we want this to happen in 4 years, so we're going to plug in 4 for T. Now I'm going to go ahead and actually plug all of this into my calculator, because to get P by itself, P is just multiplied by everything that's in the blue box. So I'm actually just going to divide both sides by what's in the blue box. So I'm going to end up with 8,000 divided by whatever all of this ends up being. Now you can go ahead and figure out what that is first and then divide 8,000 by that number, or you can plug it in all at once. I'm going to go ahead and plug it in now. Whoops. 8,000 divided by, make sure you use parentheses. In my calculator, I'm going to have 8,000 divided by, and then I'm going to put, here, I'll go ahead and write down what I'm doing. 8,000, I'm going to put this division symbol, and then I'm going to put a parenthesis and another parenthesis, 1 plus 0.0785 to the power of 4, and then another parenthesis. And so in my calculator, that's what that's going to look like. And I get that the principal amount, or my initial investment, has to be $5,913.02 to end up with that $8,000 after 4 years. Now, what if you're looking at your money being compounded more than once a year? Because the examples we've looked at so far are just when your money is being compounded once a year, but the interest can be added back into your account more than once. So the formula is going to change a little bit if the money is being compounded more than once a year. Still going to start off the same. So you have A, which is the future value, is equal to P, which is the present value, times 1 plus, and here's where it gets different, R, which is the interest rate as a decimal, divided by N to the power of N times T. N stands for the number of times that your interest is being compounded a year, so the number of times that the interest is being put back into the account. So again, N is the number of times the money is being compounded a year. Let's go ahead and look at one example of this. Okay, so a couple things to kind of point out here. Well, I probably should have put an extra space here. A few words I'd like you to kind of think about. So what I have here are different values that you would be looking at for N. So if you're looking at the interest being compounded quarterly, that's every 3 months. So the interest is being added into the account 4 times a year. So your N would be equal to 4 if you're talking about quarterly compounding. If it's semi-annually, that's every 6 months. So that's 2 times a year, which means N equals 2. If If you're talking about the money being compounded monthly, that's every month, so 12 times a year, so your N would be equal to 12. Now there's more options than this. You can talk about your money being compounded daily, which would be 365 days. If you're using the banker's rule, then you'd use 360 instead for a more rounded number. You can be talking about your money being compounded every 2 months. That would be 6 times a year, so on and so forth. So let's go ahead and look at this problem. If you invest money into an account that is subject to quarterly compounding, which means N equals 4, at an APR of 5.75%, how much will you have after 7 years if you initially invest $1,200? So we're going to be using that formula from before. I'm going to have A equals P times 1 plus R over N to the power of N times T. So we're looking for how much the account will be worth in the future, which means A is what we're trying to find. The amount that we initially invested was $1,200, so we're going to have $1,200 here for P, and then 1 plus, remember you rewrite the percentage as a decimal, so 0.075. Ooh, I messed that up a little bit. 0.0575. I'm going to make this a little bit thinner. The money is being compounded quarterly, so N is 4. Then this is all to the power of 4 times 7. You need to, when you're plugging this into your calculator, make sure that the 4 times the 7 is all in the exponent spot, so you might need to put parentheses around both of those when you're plugging it in. Again, I would suggest you pause it here and try to plug this all in yourself to make sure that you get the same thing that I'm going to get. And when I plug that into my calculator, I get $1,789.54 if I round up to the nearest cent. Now, as I was talking about before, your money can be compounded a lot of times a year. It can be compounded every day. It can be compounded every week. You know, N would be 52 in that case. It can be compounded hourly, by the minute, by the second. It can even be compounded continuously. Now, if the money is being compounded continuously, you don't have a specific number to plug in for N, and the formula actually ends up looking a little different. With continuous compounding, your formula is going to look like A equals P times E to the power of R times T. Everything stands for the same thing as before, so A is still the future value, P is still the principal or the initial amount, we call it the present value in this section, R is still the interest rate as a decimal, T is still the time in years. E is actually a button that you have on your calculator. E is a specific number. It's always about 2.718, blah, blah, blah. It keeps going forever. And your calculator, probably maybe in a different color, in green or blue or something like that, has something that looks like e to the power of x. You're probably going to have to press the button that says second on it, and then the button that has the e to the power of x right above it. So let's go ahead and do one example using this. So let's say that you invest $400 into an account with an APR of 7%, subject to continuous compounding. How much is in the account after 5 years? The future value is what we want to end up finding, so we're actually going to go ahead and leave A alone. So we're going to have A equals your initial amount, which was $400, times e to the power of 0.07 times 5. Go ahead and plug this into your calculator now and see if you get what I get. I plug it in, I get $581 and it goes 0.9965 blah blah blah, so I'd have to round up to $582. So really quickly here we're going to talk about effective annual yield and then we'll call it good. Effective annual yield looks for the simple interest rate that you have, or so the interest rate over all the time that you're looking at, not per year anymore. So all of the variables stand for the same as before, except y is the new interest rate. have time to go through a problem of this, but I'm going to go ahead and say you should always expect it to be very similar